A mole of material is simply the relative mass expressed in grams. For example, 1 mole of hydrogen gas, H2, has a mass of 2 grams. 1 mole of magnesium has a mass of 24.3 grams. A mole of material has 6.02 times 10 to the 23 number of particles, that is, Avogadro's constant. So our 2 grams of hydrogen gas contains 6.02 times 10 to the 23 number of molecules, and our 24.3 grams of magnesium has the same number of atoms. In chemistry, we work in moles because we are interested in the number of atoms and molecules rather than simply just the mass. There are 3 triangles for working out mole calculations. These include the mass over Mr. Mole, where m is the mass of substance in grams, and big M is the molar mass, and m is the number of moles, that is, the amount of substance. There is the triangle for when working with solutions, which is n over Vc, where n is the number of moles, V is the volume of solution in decimeter cubed, it's important to remember that, and C is the concentration in moles per dm cubed. Finally, there is the triangle for gases, where V is the volume of gas and N is the number of moles. Let's work through some examples using these triangles. If we have barium solid reacting with water to produce barium hydroxide and hydrogen gas, 0.3 grams of barium was added to 200 centimeter cubed of water. How many moles of barium reacted? For this, we need to change the mass into the number of moles, so we need the mass over Mr. Mole triangle. We cover the N, as this is what we want to find out, and we get the formula of mass over molar mass. If we look at the periodic table, we see that the molar mass for barium is 137.3 grams per mole. So taking our mass of barium as 0.3 and dividing by 137.3, we get 2.185 times 10 to the minus 3 moles. Now if we are asked how many moles of water reacted with 0.3 grams of barium, we look at the equation and we see 1 mole of barium reacted with 2 moles of water. Therefore, 2.185 times 10 to the minus 3 moles of barium will react with 2 times 2.185 times 10 to the minus 3 moles of water, which will equal 4.37 times 10 to the minus 3 moles. Then, if we are asked to calculate the volume of hydrogen gas, we look at the equation and we see that 1 mole of barium produces 1 mole of hydrogen gas. Therefore, 2.185 times 10 to the minus 3 moles of barium will produce the same number of hydrogen. If we were then asked to calculate the volume of gas produced in centimetre cubed, we could use our gas triangle. Because we have been asked to calculate the volume in centimetres cubed, we need to use 24,000 in our gas triangle. We cover V for the volume, as this is what we need to find out, and we get the formula V is equal to 24,000 times N. So V is equal to 24,000 times 2.185 times 10 to the minus 3, which gives 52.4 centimetre cubed to the 3 significant figures. If we needed to calculate the concentration of barium hydroxide at the end of the experiment, we would use the solution triangle of N over Vc. We know from the equation that 1 mole of barium gives 1 mole of barium hydroxide, and so 2.185 times 10 to the minus 3 moles of barium would give the same number of moles of barium hydroxide. Now we use the formula for concentration of C is equal to N divided by V, where our volume of solution is 200 centimetres cubed. So we get 2.185 times 10 to the minus 3 divided by our volume of solution. Now this is where you need to be careful, as the volume needs to be in decimeters cubed, which means dividing the 200 centimetre cubed by 1000. So we have concentration is equal to 2.185 times 10 to the minus 3 divided by 0.200, which equals 0.010925 moles per decimeter cubed.